This is lesson 42, graphing linear systems. For our warm-up, we're just asking to substitute in for x and y and see if we're trying to make sure that our points fit with this equation of our line. So when we substitute in, we'd say 2x minus 3y equals 5. And for this first one, we could use 1, 0. So we're substituting in a 1 and a 0. 2 times 1 is 2. Negative 3 times 0 is 0. And does 2 equal 5? No, this does not work, so that's a no. Our next one, we're going to substitute in a negative 1, 1. So negative 1 and 1. 2 times negative 1 is negative 2. Negative 3 times 1 is negative 3. And those add together to make negative 5. So that doesn't work either. Our next one, so that was a no as well. Our next one, negative 1 and 1. Sorry, 1, negative 1. 1, negative 1 makes 2. Negative 3 times negative 1 makes a positive 3. And 2 plus 3 equals 5. So this one must be a yes. Our last one, for 1. So plug in a 4 for x and a 1 for y. 2 times 4 is 8. Negative 3 times 1 is negative 3. And 8 minus 3 equals 5. So 5 equals 5. So this one is a yes. So what does this mean graphically? Well, so let's graph this equation. The graph of our equation would be, we're going to graph this. So that's 2x minus 3y equals 5. So we can, what's that graph look like? The graph looks like let's try this again. Should be a 2. So we can graph this. Our graph would look something like this. And we can plot these points. Remember our orange point here, 1, 0. We've got 1, 0 right here. And we can see that's not on our line. Our purple point, negative 1, 1, negative 1, 1, right here, that's not on our line. Our red point, 1, negative 1, that's right on our line. And our green point, 4, 1, that's right on our line. So we can see graphically how those other two lines didn't fit the equation. The line doesn't go through that point, or the points aren't on the line. So today, this is lesson 42. We're solving linear systems by graphing, and that's exactly what graphing is. By graphing, we're going to graph a linear system, and so that would mean another line. So we'd have another line coming in here, and now the solution to a system is where these two lines intersect each other. So that's our solution. That's what we're going to be doing today, is graphing two lines and having a solution where those lines run into each other. So checking for an intersection point, that's exactly what we just did in our warm-up, except now instead of having one equation, we've got two equations. So we say, well, that point looks like 2, -1. So we're going to do the exact same thing we did. We're going to take this top equation and we're going to plug that in to 2, -1. So 3 times x plus 2 times y equals 4. And we're substituting in a 2 and a -1, so 2 and a -1. And we say 3 times 2 is 6, 2 times -1 is -2, and 6 minus 2 is 4, so 4 equals 4. So yes, this one does fit. And now we can do our other equation. Our other equation is -x plus 3y equals -5. And again, we're going to substitute in a 2 and a -1, so a 2 and a -1. -1 times 2 makes -2, 3 times -1 makes -3, and -2 minus 3 equals -5. So that's a yes as well. So that's how we check to make sure that our point is actually that point. That point is actually where both those lines intersect each other. This is our steps to graphing a solution of a system. And so the important stuff is that we're going to write the equation in a form that it's easy to graph. So we want to put in whatever it says, 3x plus 17 equals 17y equals 2. Is that the easiest form to graph in? I don't know. We'd have to check. So graph both equations in the same coordinate plane. So same coordinate plane. Estimate the coordinates of the point of intersection. So find the point of intersection and then check the coordinates algebraically by substituting each equation into the two original systems. So our first example, you guys should pause this and try and do this. We've got, call this top one, this is y equals 3x minus 1, y equals 3x minus 12, so y equals 3x minus 12, and our point right here is 3, -3, 3, -3. So we're going to plug in a -3 for y, these are x and y, and a 3 for x, and say 3 times 3 is 9, and 9 minus 12 is -3. So yes, that works. And then we could say, does our other equation work? That's y equals -2x plus 3. Y equals -2x plus 3. Again, we're using the point 3, -3. So -3 equals -2 times 3, which is -6 plus 3 makes -3. So that's a yes. So there, we just proved those that point 3, -3 is on both those lines. Our next example, actually graphing these equations. So our first equation, x plus y equals -2. So is this in a form that we can graph? And I'd say yes. We can do the x and y intercepts. Our x-intercept, we cover up the y with our finger and we get x equals -2. So our x-intercept is over here at -2. Our y-intercept, cover up the x with our finger and we get y equals -2. So our y-intercept is -2. Down 2 over 2. Looks like it's also the same as going down 1 over 1. And that's that graph. And our next one, 2x minus 3y equals negative 9. Now immediately here I see if I'm going for my x-intercept and I covered that up, I'd need to divide by 2, so I'd say, 2x, I covered up this part of it, I need to divide by 2, and that would be negative 9 halves, or 4 and a half. So I don't really want to put a point out here at, negative 4 and a half, but we know we're going to be going through there, so we might as well. But let's solve this for y anyway. So what would we need to do? We'd need to add 2x to both sides if we're trying to solve for y. And we get negative 3y equals 2x minus 9, divide by negative 3, and we get y equals negative 2/3 x. Two negatives make a positive plus 3. So now what's our y-intercept? Our y-intercept is 3. What's our slope is up 2, or sorry, down 2, right 3, so down 2, and we messed up here. So this second equation we messed up on. Let's start this over. Holy moly, I missed a sign. This is 2x minus 3y equals negative 9. We subtract 2x from both sides, and I added it just before. Why did I do that? So negative 2x minus 9. Now when we divide by negative 3, we get y equals 2 negatives makes a positive, 2/3 x, 2 negatives makes a positive again, and now we've got a y-intercept at 3, going up 2, right 3, up 2, and right 3. That means we're going down 2 and left 3, and that takes us right through that point. Down 2 and left 3. And now we just proved that our point of intersection right there is negative 3, 1. And so now to check ourselves, we'd substitute those values back into our original equation. So here was our original equation. So oops, I erased a y. I better put that back in there. So we've got a y there. So first, x plus y equals negative 2. Substituting in a negative 3 for x and a 1 for y, and so we get negative 3 plus 1 equals negative 2, negative 2 equals negative 2. It works for that one. For our orange equation, 2x minus 3y equals negative 9. Substituting in a negative 3 for x and a 1 for y, that's negative 6 minus 3 equals negative 9. And that's negative 9 equals negative 9. So that works. So let's call this one our green equation. Negative 2x plus y equals 2. Can we graph that very easily? Well, yeah, we can, but we can also do one step and put it in slope-intercept form. And hopefully we're all good at doing that. So we've got a y-intercept of 2 and a slope of 2. And our next one, x plus y equals negative 1. We could do the same thing. We could subtract x, and we'll get y equals negative x minus 1. Y-intercept of negative 1. Slope of negative x, down 1, right 1. Up 1, left 1. And now that I'm thinking about making my mistake, or a second ago. Remember, if you guys will point these, I know I make mistakes. Sometimes I even do it on purpose. And if you point them out, I'll give you guys some extra credit. So you gotta come to me in class and say, hey, Mr. Gill, you messed up on this video, and we'll give you some extra credit for that. So it looks like our solution here is -1, 0. And our homework today is homework 42.